Hello everyone, we're a student from UT Arlington working under the supervision of Dr. Chow Kinlu from Mathematics Department. In this video, we'll discuss the concept of vortex and its mathematical expression. So if you're familiar with fundamentals of fluid mechanics, then you must have learned that vorticity, which is a curl of velocity, can represent vortex. However, does this definition of vortex through vorticity holds true for both rigid body and fluid rotation? According to our research, vorticity accounts for both rigid body rotation plus shear. In rigid body, there is negligible to zero shear, hence vorticity can represent vortex. However, for the fluid rotation, we need to consider pure shear deformation as well. This implies vorticity cannot represent fluid rotation. For the experimental verification, we recreated the Superior's famous video on fluid mechanics where he showed fluid rotation using vorticity meter, but we express our doubt if this is a proper way to represent fluid rotation. So we created a laminar flow in the long channel device and added a vorticity meter in it. As you can observe, the vorticity meter in the channel is rotating. So then we replaced the vorticity meter with an ink tank. Here you can see the ink is flowing in the straight line and we did not observe any forms of rotation or a curl. With that, let's summarize the content of this video. For rigid body rotation, vorticity is the same thing as that of vortex as it lacks shear. However, fluid does not have the same properties as that of rigid body. In fluid rotation, there is a pure shear deformation that needs to be considered. Hence, vorticity cannot represent fluid rotation. Thank you for watching.